Hey guys, welcome back. Today we are going to add the remaining components in our project. For example, solar collector and thermal storage and analyze the performance of the system. So let's get started. I will move this a little to right so that we have some space. Okay. Here. Okay, let's add the thermal storage. So we will use a stratified storage tank, fixed inlets, uniform losses, type 4A. So I will move it to 15 cubic meter and I will use 10 nodes, and I need to change the boiling point of water to 200. Okay. Okay, alright, and I will change the auxiliary heater mode to 0. Zero. Okay. Okay, everything is okay here. So next we have we will add one solar collector. So I have solar thermal collectors evacuated type 71. So I will change the collector area to 560 square meter, and now I need to change the flow rates, intercept efficiency, negative first order efficiency coefficient, and second. So I will take these values from this paper. If we go down, here are the values for ATC 8.02, A0, A1 5.4, A2 0.0576, mass flow rate is 64 kg per hour per square meter, and IAM at 50 is 1, and IAM at transverse at 50 is 0.93. So I will change these values. Okay, let's go to flow rate at testing condition 64. Intercept efficiency is 0.802. A1 is 5.4 and 0.00576. Okay, and one more thing, if you open the default file you may have different values here, but I am using 50 for longitudinal and 50 for transverse, and the values here are 1 and 0.93. so if you multiply these both, so it will give us 0.93. remember, these are the multiplications, so you need to be careful. These values are taken from the actual solar thermal collectors. Okay, so this is okay, and I think we change more. Okay, and now we will add the weather data. I have a weather data of Islamabad as in this paper, so I will load it. Okay. Okay, here. Observe this. One more thing here. The number of angles I need to change to 1 because in default it was 5. So I changed it. Okay, so let's connect the data here. So ambient temperature will go with ambient. Angle of incidence or tilted. Okay, incident radiation, total radiation here. Sky diffuse radiation, angle of incidence, solar incidence angle, solar angle, azimuth angle here. Okay, I need to change the slope. So the optimum is 13. I will put this 13. Okay, and one more thing, I need to add a pump here. So pumps single speed here. Here. Okay, and I need to calculate the flow rate. So for flow rate we have 64 kilogram per hour per square meter multiplied by 560, so we will get 35,840. 35,840 kilogram per hour. Okay, so temperature to heat source, flow rate to heat source. Outside, okay. Here. Yeah. Okay, now we connect this. Temperature to load, flow rate to load, and we need to connect on here also. Hot water flow rate will go to cold side. So here. So we will connect the ambient temperature with the environment temperature. And one more thing here, we did not change. Make it 0 and 0. Okay, so this one is okay. So I think it's okay now. We can, yeah, one more thing, or let's just try if it's working or not. So it's working very well. So we will add some equations here. For example, I want to operate the solar collector only when outlet temperature is greater than the inlet temperature. So I will add an equation here. So I say T collector one input and T output will be a signal Y. So it should go to trans edit like it is in the documentation. You go to trans edit, you will see there is a function gt, so it will return 1 if the first expression in parentheses is greater than second, return 0 otherwise. So we will use this one. So gt means that if the collector temperature is greater than the pump temperature, it will operate, otherwise it will not operate. So if you notice it is red, so it means that we are not putting the correct notation. So T and pump, now it's black, it means it's good, comma, T collector, comma, T pump. Okay, close it. Now connect it. Okay. Outlet collector and T pump, and now the output will go to pump. Control signal. Okay. This is okay, and let's check now the output. The online plotter. Quality collector to use. Okay, 200. So the outlet of temperature is around 118, 113, 14, so it's good. Okay, let's check the performance now. So we will add integrator, utility, integrator type 24, input. We have two variables, so we will, one is the useful gain and the other is the auxiliary low energy. Now we will print it. So we go to output, printer, unformatted low units type 25. Terminal we need to make it 2. and the last values. This is time, so this is the useful, and this is Q auxiliary. So we will calculate the solar reflection, which is Q useful divided by Q useful plus Q auxiliary. So Q useful divided by Q useful plus Q auxiliary. So it is about 74%. So this is the overall performance, but if we want to calculate instantaneous solar reflection, so we can do that with another equation. So we say Q useful Q auxiliary, and we call it solar reflection. So it will be Q useful divided by Q useful plus Q auxiliary plus. So here you need to be careful, because sometimes the Q, when system is not working, it will become 0, and when something divided by 0, it will go to infinity and it will give an error. So you need to add a little factor. Let's say I add 0.001. It will not have any effect in the system and it will not give us error. Close, and we will add a printer also, online plotter. Okay, so we will connect this with this. Useful with this void energy, solar reflection, make it so you see here the solar reflection changing. Sometimes it is 1 when it is all working on the solar. When auxiliary is working, it is decreasing. Now it's 0.3, 0.27, 0.17, 0.26. So it's an instantaneous solar reflection. So far we have worked on this configuration. I show you. So this loop is working like this and this loop is working like this, simple. But if we want to change, for example, I want this system to work when only the solar collector has temperature of above 108 degrees and it will provide water to the chiller. Otherwise, it will keep heating here, and this portion it will be working only on auxiliary. Whenever the temperature is above 108, it will go directly here. Otherwise, it will keep circling like this. So in the next video, we will try to add some T's and check again the performance of the system. So until then, I hope you enjoyed the lesson. So I wish you good luck. Have a good day and bye.